Hello everyone, welcome to ENK Academy. Today's video is about factorizing algebraic expressions. We're going to learn how to expand brackets and how to factorize expressions. At the end of this video, you should be able to expand or multiply out brackets, and you should be able to factorize an algebraic expression. Before dealing with factorization, let's learn how to expand bracket. Expanding or multiplying out bracket is a key algebra skill. You have to multiply the expression outside the bracket by everything inside the bracket. Let's assume we have 4n bracket n squared plus 2. In this way, you need to multiply 4n by n squared and also 4n by 2. The first expression will be 4n times n squared. We get 4n in the power 3 plus 4n times 2 will give us 8n. So this is how we can expand bracket. So what we have done here is 4n times n squared, and for this expression we have done 4n times 2. In the same way, we may have just a simple term, 5 times 3 plus 2x. What we do, 5 times 3, which is here, and then 5 times 2x, and then we get 5 times 3 plus 5 times 2x. It's 15 plus 10x. This should be given as 5 times 2x. So you need to be careful with negative signs in front of the bracket. Let's assume we have x minus 2, x minus y. What we do is that x is alone, it comes here, and then we multiply first the parentheses, knowing that the minus sign belongs to 2, and therefore we have to say minus 2 times x, that gives us minus 2x, and minus 2 times y, minus 2 times minus y, that gives us plus 2y. This can also be written as minus 2 times minus y, minus times minus gives plus. This can be continued. X minus 2x gives minus x plus 2y. This is the expanded form of our expression. So we can use the grid method. If we take x plus 7 times x minus 5, what we can do is to set it up as a grid where we have x and then minus 5. We make a grid here. On this side we have x and then 7. So we can then multiply x times x, we have x squared. X times minus 5, we have minus 5x. 7 times x, we have 7x. 7 times minus 5, we have minus 35. And we can then add all the terms inside this grid. What we will have is x squared minus 5x plus 7x minus 35. Because we have like term here, we can add x squared minus x plus 7x will give plus 2x and then minus 35. This is how we expand this bracket. So remember to collect the like terms like here, and also the negative terms belong to 5, and that is why we keep it here minus 5. There is also the acronym FOIL method, where we multiply as we did previously. If we have x plus 7 and then x minus 5, what we do, we multiply x by x, then we take x by minus 5, and then we take 7 multiplied by x, and then 7 multiplied by minus 5. So the first one, x times x, will give x squared. The second one is x times minus 5, which is minus 5. The third term is 7 times x, which is plus 7x. The last term is 7 times minus 5, which is minus 35. And then we have like terms here. We will have x squared plus 2x minus 35. We can also have another one, 2a plus b, and then a minus b. What we get, the first one is 2a times a, which is 2a times a, and this is 2a squared. The second one is 2a times minus b. That will be 2a times minus b, which will be minus 2ab. And then b times a. b times a will be ab or ba. And b times minus b will be b times minus b, which will be minus b squared. And we add all together to get a squared minus 2ab plus ab minus b squared. And because we have like terms a, b here, so the final result is 2a squared minus ab minus b squared. So this is actually an easy way to remember both the grid method and then the FOIL method, where we multiply each term in the bracket. Let's take two examples. The first one is a simple one. We have 3p minus 4 squared. If you have a number squared, that just means that number multiply with the same number. In this case, we have 3p minus 4 times 3p minus 4. And then you have the choice to use the grid or just multiply out parentheses. So we have here 3p times 3p, which gives us 9p squared. We have 3p times minus 4. We have minus 12p. Minus 4p times 3p. We have minus 12p. And minus 4 times minus 4, we have plus 16. Here we have like terms. That will be 9p squared minus 24p plus 16, which is our expanded expression. You may also have to expand and simplify x and then x minus 2 and then x plus 3. So if you have to multiply 3 factors, don't try to do it all in one step. Expand first. In this case, you can expand 2 minus 2 and 3 first, and then you multiply everything by x. In this case, we can keep x here, and then we do our method x times x, which is x squared, x times 3, which is 3x, minus 2 times x, which is 2x, minus 2x, minus 2 times 3, which is minus 6. We can even already simplify inside where we add the like terms, x squared, these two will give plus x minus 6, and now we can then multiply with the third term, which will be x times x squared, it's x in the power 3, plus x times x, which is x squared, x times minus 6, this is minus 6x. This is the expanded expression. Thus, factorizing is the opposite of expanding bracket. So if you have an expression, then you can factorize it so you have a product of factors. Let's assume that you have 5x plus 10 and you are asked to factorize. You need to look for the largest factor you can take out of every term in the expression. In this case, we have 5x, but we can also see that 10 can be written as 5 times 2. So we have a common factor here that then we can factorize, put outside the bracket. So we have 5 bracket x plus 2. If you are given to do 3x minus 1, we have 3x and minus 1. There is no common factors between those two terms, and therefore this expression cannot be factorized. But if we have 3 minus 6y, we can see that here we can write 3x minus 3 times 2 times y, and we have 3 as common factors, so we have 3x minus 2y. This is the factorized expression. So assuming we have 2x squared plus 6x, we will then have 2 times x. This can be just done inside your head without really writing it, but we are doing this to make it clear. We have common factors here and here, therefore we can express this as 2x, and x is left here, comes here, and then 3 is left here, we have x plus 3 as our factorized expression. In the same way, if you want to expand bracket, then you multiply 2x by x and then 2x by 3 to get the original expression. So it is more complicated when you want to factorize a second order expression. In this case, you need to write the expression with 2 brackets, and you need to find 2 numbers which add up to b and multiply to c. That means if we want to write this expression as x plus alpha times x plus beta, the condition is that alpha plus beta should be equal to b, and then alpha times beta should be equal to c. And the way to remember is following the table over here. If b and c are positive, then both numbers are positive. If b is positive, c is negative, then the bigger number is positive and the small number is negative between alpha and beta. If both b and c are negative, then the bigger number between alpha and beta is negative and the small number is positive. If b is negative, c is positive, then both numbers are negative. So what you see is that b is the deciding factor for the bigger number here. Let's take an example. If we have x squared plus 7x plus 10. And we are asked to factorize it. How do we do it? So we need to find two terms. When add together, we get 7. And when multiply, we get 10. In this case, what two numbers when multiplies give you 10? We have 1 times 10. We have 2 times 5. And what two numbers when added give you 7? We have 3 plus 4 and 2 plus 5. We see that those two numbers are satisfying our expression. So this one become alpha, this one beta, and we have x plus 2 times x plus 5, which is the factorized expression. As you will see, both b and c are positive, and therefore both 2 and 5 are positive. Let's now see the second case where b is positive and c is negative. And we just take the same expression we had before, x squared plus 7x plus 10. This time, let's make c negative. So we have x squared plus 7x minus 10. We know that the two number here is 3 plus 4 and 2 plus 5. Here we have multiplication will be 10 and minus 1, or the other way around, or minus 2 and 5. The bigger number should be positive. That means those ones are not valid. So we need a bigger number between those two that should be positive. In this case, 10 and 5. But if you add 10 and minus 1, doesn't give you 7. And 5 and minus 2 doesn't give you 7. And therefore, so we cannot factorize this expression here. However, if our expression was x squared plus 7x minus 18, we can see that the bigger number should be positive. That means 9 times minus 2. And then we also have 6 times minus 3, because the small number should be negative. We also have 18 times minus 1. If we now look at the sum, 9 plus minus 2 is 7. 6 plus minus 3 is 3. So we see that 9 plus minus 2 is 7. This one gives 6. This one gives 17. And therefore, these two terms, 9 and minus 2, are the one that are our factors. And therefore, we have x plus 9 factorize x minus 2, and this is the factorized expression of x squared plus 7x minus 18. As we see, the bigger number is positive, the small number is negative. If we now take the case where both b and c are negative, let's still look at our previous example. Let's make b and c negative. So we have x squared minus 7x minus 10. In this case, the bigger number is negative. So here what will happen, we might have minus 10 times 1. We might have minus 5 times 2. And we see that x minus 10 plus 1 is minus 9. Minus 5 plus 2 is minus 3. And this expression cannot be factorized. However, if we had x squared minus 2x minus 15, then the bigger number should be negative. Minus 5 times 3 is minus 15. Minus 15 times 1 is minus 15. And we see minus 5 plus 3 equal to minus 2. minus 15 plus 1 equal to minus 14. So this is alpha plus beta, and this is alpha times beta. We see that these two numbers correspond, so this expression can be written as x minus 5 times x plus 3. That means the bigger number is negative and the smaller number is positive. For the last term, if we take our previous example, now let's make b negative. We have x squared minus 7x plus 10. Both numbers should be negative, and therefore the product here will be minus 5 times minus 2, and also minus 10 times minus 1. As we see, minus 5 plus minus 2 is minus 7, minus 10 minus 1 is minus 11, so this expression is the 1, so our expression is x minus 5 times x minus 2. This is how you factorize expressions. Usually you may have the difference of two squares. You can factorize expressions that are written as something squared minus something else squared. For example, x squared minus b squared. The rules are simple. If you have something squared minus something else squared, what you get is the same expression times the same expression with opposite sign. So a minus b times a plus b. That means if you have x squared minus y squared, you will have x minus y factorized by x plus y. You can check it. If we multiply x by x, we have x squared. X by y, we have plus xy. Y by x, we have minus xy. Minus y times y is minus y squared. And these cancel each other. And then we have x squared minus y squared, which is the original expression. Thank you very much for watching this video. I hope you have learned how to expand bracket and how to factorize expressions. I will encourage you to subscribe and be empowered.